Look at a cat for long enough, and you start noticing something strange. Every twitch, every stare, every silent judgment goes back further than you think. Not centuries, not millennia, billions of years. This is the story of how a single cell became a cat. Not a legend, not a guess. A trail of fossils, DNA, and a few genuinely strange coincidences. Let's start at the very beginning, before there was fur. Before there were bones, before there was anything alive at all. About 3.8 billion years ago, Earth was a very different place. The atmosphere had almost no oxygen. The oceans were warm, chemical, and completely empty of anything we'd call life. Then, somewhere in that early ocean, something crossed a line. A cluster of molecules started copying itself. It built a wall around itself to keep its own chemistry contained. Scientists call this LUCA, the last universal common ancestor. It wasn't a plant. It wasn't an animal. It wasn't really anything you'd recognize. It was just a single cell, barely holding itself together. But it did one thing that changed everything. It survived long enough to divide. And every living thing on Earth today, every cat, every human, every mushroom, traces back to that one moment. For a very long time, that was it. Cells surviving, nothing more. For roughly 2 billion years, life on Earth was just bacteria doing bacteria things. Then, around 2 billion years ago, one simple cell absorbed another, and instead of digesting it, kept it alive inside. That absorbed cell became a tiny internal power plant we now call a mitochondrion, and every cell in a cat's body still has thousands of them. This merger created the first complex cell, the eukaryote, with more room and more energy to get complicated. And complicated is exactly what happened next. Around 1.5 billion years ago, some of these cells stopped separating completely after dividing. They started sticking together instead. That's the entire origin of multicellular life. Cells that simply didn't let go. Unglamorous, sure, but it's also the reason a cat is one animal instead of a trillion separate ones. For hundreds of millions of years, these early organisms stayed soft, squishy, headless, and barely shaped at all. Then, around 540 million years ago, something set off an explosion. Not a literal one, a biological one. Geologists call it the Cambrian Explosion, and it's one of the strangest events in the history of life. In a geological instant, just a few million years, animal body plans diversified at a staggering rate. Shells appeared, eyes appeared, legs appeared, and somewhere in the murky Cambrian seas swam a small, unassuming creature called Pikaia. Pikaia was about 2 inches long, shaped like a flattened worm, and utterly unremarkable to look at. But it had one thing that mattered more than anything else in this story, a flexible rod running down its back, called a notochord. That rod is the ancestor of your spine, and your cat's spine, and the spine of every vertebrate that would ever exist. Pikaia wasn't a fish, it wasn't even close, but it was the opening move in the direction of every backboned animal on Earth. From creatures like this, true fish eventually emerged. Jawless at first, just filter-feeding tubes drifting through ancient seas. Then, around 425 million years ago, the jaw appeared, and everything changed. Jaws let animals grab, bite, and actually hunt instead of just filtering water. Fish with jaws exploded in variety, and among them were the Lobe-Finned fish, a group with thick, muscular, oddly limb-like fins. Most fish fins are thin and flexible. Lobe fins had real internal bone structure, a rough preview of an arm, quietly rehearsing a much bigger move, moving onto land. Around 375 million years ago, in shallow, oxygen-poor swamps, a creature called Tiktaalik appeared. Tiktaalik had gills and scales like a fish, but it also had a flat head, a mobile neck, and fins with wrist-like bones inside them. It could prop itself up in shallow water and maybe, just maybe, flop onto mud for short stretches. It's not quite a fish. It's not quite a land animal. It's the transitional creature scientists spent decades looking for, and in 2004, they finally found it. From animals like Tiktaalik came the first true tetrapods, 4-limbed vertebrates built for land. Legs replaced fins, lungs backed up gills, and for the first time in Earth's history, a vertebrate could live its entire life outside of water. Every land vertebrate on Earth, amphibians, reptiles, birds, mammals, all of it starts here. But early tetrapods had one massive limitation. Their eggs had no shell, so they still had to lay them in water, just like fish. Around 312 million years ago, the amniotic egg solved that completely. A self-contained pond, sealed inside a shell that let animals move away from water for good. Almost immediately, this new group split in two. One branch toward reptiles and eventually birds, the other toward something called synapsids, the branch your cat is on. You can actually tell the difference by looking at a skull. Synapsid skulls have a single opening behind the eye socket for jaw muscles. Sounds like a tiny detail. It isn't. That one opening is the anatomical fingerprint connecting a 300 million-year-old fossil to your cat's jaw today. Early synapsids looked more like scaly, sprawling lizards than anything fuzzy. But over tens of millions of years, their legs moved underneath the body, and their teeth specialized. Some for shearing, some for grinding. These advanced synapsids are called Therapsids, and they dominated Earth long before dinosaurs existed. Then, around 252 million years ago, almost everything died. The Permian extinction wiped out an estimated 90% of all species on the planet. It remains the closest life on Earth has ever come to being completely erased. A small number of Therapsids survived, and from the survivors came the Cynodonts. Cynodonts had whiskers, possibly fur, and jaws edging closer to a true mammal bite. But the world they woke up into now belonged to someone else. Dinosaurs. For the next 150 million years, Cynodonts and their mammal descendants stayed small, mouse-sized, shrew-sized, built to be ignored. Most were nocturnal, coming out only after the dinosaurs went to sleep. And that single habit, hiding in the dark, shaped mammalian senses for the rest of time. It's a big part of why your cat can see a near total darkness today. Then, 66 million years ago, an asteroid roughly 6 miles wide slammed into the Yucatan Peninsula. The impact ended the age of non-avian dinosaurs in what is, geologically speaking, an instant. Around 3/4 of all species on Earth vanished. But small, dark-adapted mammals, hiding in burrows, survived the fire and the dust. And with the dinosaurs gone, they walked out into a suddenly empty world. What followed is called the mammalian radiation. In just a few million years, mammals exploded into an enormous range of shapes and sizes. Somewhere in this burst of diversity, a new group appeared, the Carnivoraforms. Small, sharp-toothed, agile predators built to chase down other small mammals. Around 55 million years ago, one branch became known as the Miacids, a bit like a cross between a weasel and a fox. Low to the ground, quick, and clever. They weren't cats yet, and they weren't dogs yet either. But they were the last common ancestor both groups would ever share. Around 42 million years ago, that lineage finally split in two. The Caniforms, ancestors of dogs, bears, and seals, and the Feliforms, ancestors of every cat that would ever exist. From here, the story narrows fast. Around 25 million years ago, a small, agile predator called Proailurus appeared in the forests of Eurasia. Its name literally means before cat, and that's exactly what it was. Proailurus had retractable claws, forward-facing eyes, and a skeleton built for pouncing rather than chasing for miles. It looks something like a cross between a civet and a small cat. It is, as far as the fossil record can tell us, the first true cat. From Proailurus came Pseudaelurus, appearing around 20 million years ago and spreading across 3 continents. Pseudaelurus is where the family tree really starts branching out. One line eventually led to the saber-toothed cats, animals with canine teeth the length of steak knives. Another line led to the big cats, lions, tigers, leopards, jaguars. And another, quieter line led to the small cats, the ancestors of every housecat on Earth. For millions of years, these small wildcats spread across Africa, Asia, and Europe, hunting rodents and birds. They weren't tame. They weren't friendly. They had zero interest in humans. Then, around 10,000 years ago, something changed everything. Humans in the Fertile Crescent started farming grain and storing it in one place. Stored grain attracts rodents. Rodents attract wildcats. And a specific subspecies, Felis sylvestris libica, the African wildcat, started hanging around human settlements. Nobody tamed them. Nobody trained them. The wildcats that tolerated humans got easy meals and safer places to raise kittens. And over generations, the calmer, bolder individuals simply out-reproduced the skittish ones. This is domestication by natural selection, not human design. A genuinely rare way for it to happen. Cats essentially domesticated themselves. The genetic difference between a modern housecat and its wild ancestor is remarkably small. Unlike dogs, which humans actively bred for specific jobs, cats were mostly left as they were. That's part of why a housecat can still hunt, still stalk, still pounce, almost exactly like Proailurus did 25 million years ago. Ancient Egyptians were the first to elevate cats to genuine cultural importance, associating them with the goddess Bastet, and by some accounts, treating harm to one as a serious offense. From Egypt, cats spread along Mediterranean trade routes as unofficial passengers on grain ships. A ship full of grain has a rodent problem. A ship with a cat on board does not. Sailors noticed, and within a few thousand years, the descendants of a single North African wildcat lineage had reached nearly every continent on Earth. Which brings us back to your couch. Every cat curled up in a sunbeam right now carries the notochord of Pikaia in its spine. It carries the jaw structure of a synapsid that outlived the Permian extinction. It carries the nocturnal eyes of a mammal that hid from dinosaurs in the dark for 150 million years. It carries the retractable claws of a predator that was pouncing on prey before there were any humans around to watch it. Nothing about your cat is new. Every part of it is a modification of something that came before, stretching back through fish, through the first vertebrate, through the first cell that ever decided to survive. So the next time your cat stares at you from across the room, utterly unbothered, remember what you're actually looking at. You're not looking at a pet. You're looking at 4 billion years of survival wearing fur.